all radiations, small incident radiations, है ना, none is reflected. Reflection is zero, but absorption is 100%. Right, that body is called black body, right? And that black body emit energy with perfect efficiency. Okay, it effectiveness as radiator of energy varies only as temperatures varies only as the temperatures varies, right? Basically जो black body radiations energy spectral radiance particular radiance black body B spectral radiance, that is B lambda is equals to 2h 2h c square by lambda power to the 5 into 1 by e power ch by lambda kt minus 1.
सर ये
सर
रिपीट
फॉर्मूला
करना
रिपीट कर
फॉर्मूला।
दो।
मैं इसको भेजता हूँ व्हाट्सएप में, ग्रुप में। B lambda is basically radiance, spectral radiance, right? H is, what is H is? H is Planck constant. C is the speed of light. Lambda is wavelength, right? K is Boltzmann constant. T is absolute temperatures. ठीक है?
हेलो, एक्सक्यूज मी सर।
Energy per unit
सर आपकी वॉइस ब्रेक हो रही है शायद।
हेलो, एक्सक्यूज मी सर।
yes
सर कुछ बच्चे ज्वाइन कर रहे हैं बट उनका शायद आपने एक्सेप्ट नहीं किया है इनविटेशन लिंक।
okay, so m is the directly proportional to the m. What is the m? M is basically radiation energy per unit of black body in unit time.
एक्सक्यूज
unit
मी
time
सर।
में
सर
yes
ये ब्लैक बॉडी रेडिएशन का जो आप फॉर्मूला बता रहे थे उसके बाद आपकी आवाज बीच में चली गई थी, तो रिपीट कर दो। उसके बाद जो भी आपने बोला है फॉर्मूला के बाद।
no formula के बाद बताया था b is basically spectral radiance r a d i n c radiance. T is absolute temperatures, K is Boltzmann constant, H is Planck constant, C is speed of light, and lambda is wavelength.
ओके सर।
ठीक है, तो black body is basically the absolute observer, right? Reflectance is zero, right? That is the hypothetical, totally hypotheticals. Next, Stephens Boltzmann's law is basically irradiation energy per unit time of unit black body. ठीक है, जो that is aim is directly proportional to the fourth power of the black body's thermodynamic temperature, that is T, that is absolute temperature, that is fourth power of absolute temperature. It's aim directly proportional to T power 4, right? T power 4, ठीक है, and aim is constant into T power 4, and constant is equal to epsilon and sigma, right?
सही रिपीट करना, आप क्या बोल मतलब किसका फॉर्मूला बोल रहे हो ये आप? टी की
Aim
पावर 4
defense aim directly proportional to T power 4. What is aim? Aim is basically radiation energy per unit time of a black body. Okay, that is aim. So aim is directly proportional to T power 4, right? So aim into constant into T power 4. Constant is basically sigma T power 4, right? And sigma is called emissivity. Sigma is called emissivity. That is constant. Okay.
सर टी इज टेम्परेचर।
Absolute temperatures. Okay. Next law. Next law is Kirchhoff law. Kirchhoff. Kirchhoff law. Physics में पढ़ा तुम लोग शायद. Okay. Kirchhoff law is basically law is tell about the good absorber are the good emitters and good reflector are poor emitters.
सर
Okay.
रिपीट करना।
Good observer are good emitters. Good observer is good emitters and good reflectors are poor emitter. ठीक है, so basically emission and reflection जो summation is, that is a constant 1, है ना? Reflected emitted energy at an opaque object, right? Opaque object reflected and emitted energy at an opaque object is obtained by the energy conservation law. Okay, E lambda, suppose E lambda is absorbed energy. Okay, and reflected energy is P lambda. Okay, then E lambda plus P lambda is equals to 1. Understood?
सर इसमें ई लैम्डा और पी लैम्डा क्या है?
E lambda is basically absorbed energy and P lambda is reflected energy.
ओके सर.
The absorption and reflection is basically constant, that is 1. So E lambda is, you can write U lambda is equals to 1 minus P lambda. ठीक है. And another
Sir, you're not audible.
ठीक है. Kirchhoff law is about basically the relation between reflectance and emitted energy of an opaque object. Okay. And emissivity is basically ratio between the radiant flux and radiance flux of materials and absolute black body's radiant flux. No ratio. Okay. Now, radiation interactions with the atmosphere. Okay. So radiations used for remote sensing, when a radiation used for the remote sensing must pass through the earth atmosphere, right? So one, mainly we use two type of source, or natural source and another is artificial source, right? And both source passes through our atmosphere. Okay. जब एटमोस्फेयर से जब पास होगा ना, पास होकर our object तो mainly our earth surface में, right? So our atmosphere, so बहुत सारा particles is there, right? Dust particles, right? Dust particles both in gaseous, 90% gas within up to 10 kilometers radius, na? So gas molecules, dust particles, different kind of pollutions, right? So those जो through this atmosphere जो one time in incident and other reflectance हो रहा है, reflectant हो रहा है, सेंसर भी हमारा सैटेलाइट एटमोस्फेयर में ही है ना, हाई एल्टीट्यूड में एटमोस्फेयर, तो टू टाइम इंटरेक्शन हो रहा है. एंड ड्यू टू दिस इंटरेक्शन जो our receiving reflectant energy reflected energy receiving by the sensor, quality basically impacted, substantial impact on this quality, है ना, substantial impact on this quality just because of this interaction. So therefore we have to understand the type of interaction, right, the type of interactions, right, right. So if we know the type of interaction, then we can eliminate it, this noise, this error in the our during our image processing or our interpretations. Understood? Understood? Got it?
Yes, sir.
So the solar energy जो pass कर रहा है, natural energy, there are mainly three types of interaction is there. One is scattering is possible, right? Absorption is possible, and also reflection also possible, or reflections. Scattering, right? Absorption and refractions. Okay, three type of interactions: scattering, absorptions, and reflections. Okay, so further scattering, no? Scattering is basically direction of electromagnetic energies by the particles suspended in atmosphere or large molecules of the atmospheric gases, right? तो scattering जो है ना, scattering basically स्नेल लॉ जो है वो फॉलो करता है, राइट? इंसिडेंट रे एंड रिफ्लेक्टेड एंगल परपेंडिकुलर के साथ बोथ एंगल इज द सेम ना, रिफ्लेक्शंस का लॉ है. बट ये जो रिफ्लेक्शन इंसिडेंट एंगल एंड रिफ्लेक्टेड एंगल जो डिफरेंट हो जाता है जस्ट बिकॉज ऑफ द सरफेस स्मूथनेस को ऊपर डिपेंड करता है, राइट? बट दैट आल्सो फॉलो दिस लॉ, ऑलवेज फॉलोज, राइट? नाउ this scattering जो है डिपेंड्स ऑन द पार्टिकल साइज. ओके, the amount of the scattering depend on the size of these particles and their abundance and the wavelength of the radiations and the depth of the atmosphere through which energy is traveling. So what are the factors? That number one, the amount scattering depends on the number one is size of the particles. Okay, then abundance, right? Particles abundance किया है atmosphere में. Then wavelength of radiations, and fourth is the depth of the atmosphere through which the energy is traveling. Okay, ठीक है? Now size of the scattering particles parameters depends on basically that's called factors alpha. Okay, that is called alpha, right? Alpha is basically pi into d by lambda, right? The size of scattering, particle size of scattering is basically pi into d by lambda. D is the dimension in constant, dimensionless, it is dimensionless in units, and lambda is the wavelength. Okay, lambda is the wavelength. It means जो factors है, it means दो particle, mainly the particle size के ऊपर depend करेगा, right? So scattering for the two type, selective scattering and non-selective scattering. Okay, selective scattering and non-selective. Note it. select type of scattering, selective scattering and non-selective. Selective scattering means you can predict the reflectant ray goes these directions, right? You can predict. But non-selective scattering में you cannot. Okay, ठीक है. तो selective scattering further subdivided into two types. One is relay scattering and Mie scattering. Selective scattering is Rayleigh, RAYLEIGS, Rayleigh scattering, and Mie scattering, MIE scattering. Okay, तो Rayleigh scattering जो alpha, what is the alpha? Alpha is size of particles, parameters. Alpha is less than 0.4. Okay, alpha is less than 0.4. And Mie scattering the alpha values is basically wavelength जो है Mie scattering greater than 0.4 but less than 3, greater than 0.4 and less than 3, right? And non-selective scattering is alpha value greater than 3. I repeat, scattering depends on the three factors. One is particle size, particle densities, and the depth of the particle. Depth means the thickness, right, atmosphere. So alpha is parameter जो है scattering parameter alpha, right? Alpha is the pi into d by lambda. D is constant, some constant, pi also constant, and lambda. If alpha is less than 0.4, right? So wavelength is 0.4, right? That is Rayleigh scattering, and 0.4 to 3 in between alpha values, that is Mie scattering, MIE, Mie scattering, and Rayleigh and Mie scattering, that is called selective scattering. Selective scattering means the reflectance ray ka directions you can predict, right? So unpredictable reflectance scattering is called non-selective, where the alpha value greater than 3. Okay. तो Rayleigh scattering है basically जो wavelength very fine, very small spectrums के लिए है, और particle size is very finer, जो interaction होगा particle very finer. Example is gas molecules mainly, right? Do assume the atmosphere particles have diameter that are very small relative to the wavelength of the radiations, right? So interaction है Rayleigh scattering का interaction है mainly very finer particle. In case finer particle examples क्या है? Small speck of dust, right? Some gas molecules, oxygens, nitrogens, right? That in that case Rayleigh scattering जो है okay, Mie scattering is caused by large atmospheric particles. Mie scattering है तो compared to the Rayleigh scattering size, that is particle size is 0.42 greater than 3, right? So atmospheric particle including dust, pollens, right, smoke, water droplets, right, such particle may seem to be very small by standard of the everyday experience, but they are many times larger than those responsible for Rayleigh scattering. ठीक है? And non-selective scattering is basically for larger large particle size, right? And for wavelength of scatter radiation, large longer wavelengths, okay? For radiation in and near the visible spectrum, such particle might be the larger water droplet, the large water particle in airborne dust. Okay. Now tell me, our sky is blue, right? Our sky is blue, na? Due to scattering. Which type of scattering is? Tell me.
Relic.
रेले
Right. Because of the जो गैस molecules का finer particles से reflections. Okay. Okay. Scattering behavior of three class of atmospheric particles. Right. Scattering behaviors. Right. First, जो atmospheric dust and smoke form rather large irregular particles that create a strong forward scattering peak with a smaller degree of back scattering. I repeat, first point, your scattering behavior, atmospheric dust and smoke form rather irregular properties, right, that create a strong forward scattering peak that create a strong forward scattering peak with a smaller degree of backscattering. Okay. Second, the atmosphere molecules are more nearly symmetric in shape. Atmosphere molecules are more nearly symmetric in shape, creating a pattern characterized by preferential forward and backward scattering. ठीक है? अच्छा, फॉरवर्ड स्कैटरिंग बैकवर्ड स्कैटरिंग मीनिंग क्या है?
सर डायरेक्शन का फर्क होता है दोनों में
डायरेक्शन का फर्क है, ठीक है? जो इंसिडेंट रे, राइट, स्कैटरिंग तो ऑल डायरेक्शन में ही होता है ना, तो इंसिडेंट रे दैट इज द डायरेक्शन, राइट, विथ रेस्पेक्ट टू द इंसिडेंट रे, ठीक है? तो फॉरवर्ड एटमॉस्फेरिक मॉलिक्यूल्स आर द मोर लेयरली सिस्टमेटिक इन शेप, creating a pattern characterized by a preferential forward and backward scattering, but without the right pronounced peak observed in the first example. First example means जो example है, एक image send कर रहा हूं मैं, देखो. Got it?
यस
जो figure A, that is Mie scattering, right? Mie scattering, very finer particles, right? Particles is very fine, right? But irregular patterns, right? Scattering is very irregular, right? Forward scattering is dominant with smaller degree of back scattering. Back scattering less and forward scattering is very high. But second B is basically जो Rayleigh scattering. So all backward and forward scattering, right? That all are equally dominant, right? ठीक है? Basically, without the pronounced peak observed in the first examples. जो first example mix scattering जो है उससे difference है. एक forward scattering fast mix scattering में forward is dominated, but not like that here. Third one, that is a non-selective scattering. Larger water droplets create a pronounced forward scattering peaks with smaller backwards scattering. Okay, so the forward scattering more dominated in non-selective than Rayleigh scatterings. Okay, it means particle size जितना, it depends on the particle size also, right? So Rayleigh scattering just why more all scattering or no backward and forward both are the dominant just because of the wavelength जो है visible spectrum wavelengths more or less equals to the particles size. মানে diameter of the particles and wavelength of the visual spectrum more or less same. That's why uh, equally backward and forward scattering is same. Understood? जितना difference होगा जो spectrum wavelengths and the particle size diameter is difference, right? तो इतना ही ज्यादा forward scattering increase होगा. Larger particles mean forward scattering will be more. Okay. So लास्ट टॉपिक डिस्कस करूंगा जो स्कैटरिंग्स जो है. देखो एक इमेज सो एटमोस्फेयर में जो है बेसिकली देखो एक सोर्स सन, राइट? सन सन जो है, राइट? तो एक एटमोस्फेयर में पार्टिकल्स जो है बिफोर रीचिंग टू द ऑब्जेक्ट बस ऑब्जेक्ट, तो उसमें रिफ्लेक्टेड होके सेंसर में इमेज रिसीव कर सकता है, राइट? अदर जो टारगेट टू रिफ्लेक्टेड होके एटमोस्फेयर में जाएगा, टारगेट से रिफ्लेक्टेड होके भी सेंसर में जा सकता पॉसिबिलिटी है ना? तो व्हाट इज द एरर जो हो रहा है बेसिकली एटमोस्फेयर के साथ जो रिफ्लेक्टेड स्कैटरिंग मेनली रिफ्रैक्टेड एंड स्कैटरिंग फ्रॉम एटमोस्फेयर इंटरेक्शन, राइट? दैट इज बेसिकली जो ISIOID. IS is reflected from the ground, right? IS is the Understood? Am I audible?
पहले नहीं थे सर, अभी आई है आवाज।
Okay. So your I is equals to I is the total energy received.
सर IS के बाद
No,
क्या
no.
क्या था?
Capital I is the received by three way. Three way. Number one is the reflected from the ground, or it's mean reflected from your study area, reflected from your objects, target, your object, your study area, right? And IO, it is also possible scattered by the atmosphere directly to the sensor. Scattered by the IO, scattered by the atmosphere directly to the sensor. है ना? And ID is diffuse light directed to the ground than to the atmosphere. Okay.
सर रिपीट कर दो प्लीज।
I is the total energy, है ना? Receive total energy I is the reflected from the ground or your target or your objects. Okay.
यस सर।
IO is basically scattered by the atmosphere directly to the sensor. ठीक है?
यस
Right? Just scattering, amount of total scattering, atmospheric scattering, and ID is basically
हेलो।
am I audible? Am I audible?
Yes, sir.
Okay. Last topics. थोड़ा नेटवर्क इशू है मेरे पास। जो I है, I is the total energy received by the sensor, है ना? तो टोटल जो एनर्जी रिसीव किया है, तो दैट उस डेटा को हम लोग प्रोसेस करके इंटरप्रेट करना पड़ेगा ना। तो दैट डेटा जो रिसीविंग डेटा इज नॉट द प्योर डेटा. प्योर मीन्स प्योर डेटा किसको बोलूंगा? जो डेटा हमको टारगेट एरिया से रिफ्लेक्ट हो रहा है, ओनली रिफ्लेक्टेड बाय द टारगेट, राइट. एंड इट इज द कॉम्बिनेशन ऑफ थ्री टाइप्स ना, आई एस, आई ओ, आई डी, है ना. तो आई एस इज योर द एक्चुअल डेटा, राइट. आई ओ इज नॉइस एंड आई डी ऑल्सो नॉइस, राइट. IS क्या है? IS is reflected from your ground target. IO is scattered by the atmosphere directly to the sensor. And ID is also कैसे है? जो टारगेट से तुम एटमोस्फेयर में गया है, एटमोस्फेयर में फर्दर सेकेंड टाइम स्कैटर्ड होके टू द सेंसर में रिसीविंग हो रहा है. दैट इज ऑल्सो सेकेंडरी नॉइज, है ना.
यस सर।
अंडरस्टूड. आई रिपीट वन मोर टाइम्स. देखो जो सेंसर जो रिसीविंग होगा, फास्ट तो है तुम्हारा स्टडी एरिया, बट टारगेट से रिफ्लेक्टेड. दैट इज द एक्चुअल, तो दैट इज आवर रिक्वायर्ड एनर्जी है. इतना एनर्जी हम लोग को जो चाहिए. बट ड्यू टू द इंटरेक्शन, फर्स्ट इंसिडेंट रे सन से आ रहा है एटमोस्फेयर में, एटमोस्फेयर में इंटरेक्ट होकर रिफ्लेक्टेड होकर बस स्कैटर्ड होके सेंसर में जा रहा है, राइट. दैट इज आईओ, राइट. एंड आईडी इज ग्राउंड में आया है, स्टडी एरिया में आया है, देन रिफ्लेक्ट होकर जा रहा है. रिफ्लेक्ट होकर जब जा रहा है तो पाथ तो क्या है? पाथ तो एटमोस्फेयर ही है ना. तो फर्दर स्कैटरिंग होने के चांसेस है, स्कैटरिंग रिफ्लेक्शन है. तो दैट रिफ्लेक्ट होके फर्दर तुम रिसीविंग हो रहे हैं सेंसर. दैट इज द आईडी, राइट. तो वी हैव टू eliminate the IO and ID during our image processing to eliminate the noise, है ना. तो तुमको IO ID को आइडेंटिफाई करना है. अंडरस्टूड. दैट इज द मेन ऑब्जेक्टिव ऑफ दिस स्टडी. आज का जितना डिस्कशन किया है ना. ठीक है. एनी डाउट, क्वेश्चंस?
सर पार्टिकल साइज जितना बड़ा होता है उतनी ज्यादा फॉरवर्ड स्कैटरिंग होती है.
हाँ, इतना ज्यादा फॉरवर्टेड होगा. एंड दैट इज नॉन सिलेक्टिव. नॉन सिलेक्टिव मीन्स यू कैन नॉट प्रेडिक्शंस नहीं कर सकते तुम एग्जैक्टली कौन सा डायरेक्शन जाए. दैट्स नॉन सिलेक्टिव. सिलेक्टिव में इसका मतलब जो तुम जो रिफ्लेक्टेड है, फॉरवर्डिंग रे को, तुम फॉरवर्डिंग स्कैटर को तुम प्रेडिक्ट कर सकते है ना.
यस सर.
ठीक है. मोर diameter particle size, more forwarding scattering, right. And this is non selective scattering, where alpha value is greater than 3. What is the alpha? Alpha is basically 4 d pi by lambda. Okay. Okay, any more questions, doubt?
नो सर।
Okay. एक काम करो, अटेंडेंस व्हाट्सएप में ड्रॉप करो. नेक्स्ट डे से वेडनेसडे 11 o'clock ना.
यस
ठीक है.
सर.
टुमारो
Yes, sir.
प्रैक्टिकल्स के लिए कुछ मैं भेजूंगा, टुमारो तुम कर लेना कभी. है. ओके.
ओके सर।
एक मिनट, जस्ट अ मोमेंट, वेट फॉर अ मोमेंट. Just